in this question, we have a pendulum with a bob of mass m hanging in a ship sailing from east to west along the equator. When the ship is stationary, the tension in the string is T naught. Angular speed and the radius of the earth is given. We need to first find out the speed of ship due to earth's rotation. Now let us draw the diagram. The ship is initially still, therefore it is rotating along with the earth. The earth is rotating with angular velocity omega, so any point on it is also rotating with angular velocity omega about its axis passing through the center. Therefore the velocity of this point will be equal to omega r due to its circular motion. Therefore the speed of the ship as it is stationary due to the earth's rotation becomes omega r. This is our answer for the first part. We now need to find out the difference between T naught and the earth's attraction on bob. For this, let us draw another diagram. This ship is doing circular motion and there is a pendulum hanging on the ceiling of the ship. Now there is a tension acting on this bob in the upward direction, that is a pulling force, and the gravitational force acting towards the center. Now since this object is performing circular motion with angular velocity omega, therefore we can write Fg minus T, this is the net centripetal force, this is equal to m omega square r. Now we need to find out the difference between T naught, this tension is given to be T naught since the ship is at rest now, therefore the difference between T naught and the earth's attraction on bob is equal to m omega square r. So the answer for the B part comes out to be m omega square r. Now the third part is interesting. It says that if the ship sails at speed v from the direction east to west along the equator, then we need to find out the tension in the string. For this part, let us see, if the ship is sailing east to west and the earth is rotating from west to east, therefore the net resultant velocity of the ship comes out to be v minus omega r, that is v this side and omega r this side due to earth's rotation. So the net speed of the ship comes out to be v minus omega r. Therefore the bob of the pendulum seems to be doing a circular motion with velocity in the orbit equal to v minus omega r. Now we can write down the gravitational force Fg minus the new tension, this is equal to m v square by r, where v is equal to v minus omega r whole square upon r. Let us expand this. Fg minus T dash is equal to mv square by r plus m omega square r minus 2m v omega. Now here we already know that Fg minus T naught was equal to m omega square r. Therefore we can write from B part, we knew this, therefore we can write Fg minus m omega square r is equal to T naught. Therefore Fg minus m omega square r becomes T naught is equal to T dash plus mv square by r. We bring plus 2m omega on this side, omega v. Therefore T dash becomes equal to T naught plus 2m omega v minus mv square by r. Now this can be written as m into v upon r. Now this v upon r is very negligible as compared to omega, so we can neglect this term to get the final answer as T dash is equal to T naught plus 2m omega v. So if the ship sails from east to west with a velocity v, then the tension in the string comes out to be T naught plus 2m omega v.